One of the things that KiCAD doesn't do incredibly well is draw board outlines. They've significantly improved over the past few versions from 5 to 6 to 7, and we're now at a pretty good place. You can draw lines. I think if you press Control Shift, you can draw straight lines. So we draw, say we're trying to make a rounded rectangle. Set the separation between these. Let's see, 30 millimeters. I want to set this to, let's say, 100. Okay, draw an arc. This is not my strong suit. All right, so we want to go over here. Boom. 90 degrees. Place, draw a line over 0 degrees. Go. Place, draw arc. Now, maybe you're the kind of person who can make this work. I'm sure they're out there. You know, you can make a rounded board of this type function. And you can go through and you can make sure that all of the dimensions are right and that you've got the curvature correct and all of those things. But it's not a system that's designed for it. You know, it's not intuitive, it's not super easy, it doesn't guarantee correctness, so it's something that I like to avoid. Especially if you're trying to do a more complicated shape, doing it with these rudimentary tools is a little error prone, to put a nice word on it. So let me show you the way that I do it. Here is an example project. I have, that's actually the imported PCB. So here's the sketch. It's pretty easy. You make the sketch of the rounded rectangle in FreeCAD, then you import it as an SVG into KiCAD, save it as a part, and then use it just as you would any other part in your library. You put it on your schematic. Here it is in the schematic with the footprint. Here's the footprint. Look at the 3D model. It's just a part like any other, except it's also the board outline. So let me show you how it is that I do this. I'm sure that some of you watching this are more of a FreeCAD and more of a KiCAD expert than I am, but here goes. All right, so we just want to set, make a rounded board, 100 millimeters on either side with 4 millimeter curved edges. I like 4 millimeters. It looks good with M3 hardware, like mounting holes. So we want this to be square, so we have to set those to be equal. You should all be equal already, so I only have to select one. Set diameter, 4 millimeters. Okay. I always press escape and get out of it. What degree of freedom am I missing? All right, so I need to set this to 100 millimeters. Go. I need to stop pressing escape all the time. It turns green, which means we're fully constrained. And then I always like to make it into a 3D object before I export it. I don't know, make it the thickness of the board, 1.6 millimeters. Go to the body, file, export. I always do SVG. It just works better for me. You can also use DXF. I think there might be a couple other formats you can use. Not positive. You can definitely make it a PNG and then re-import it. But SVG is very reliable format for this, so that's what I always use. Highly recommend. So you export it, save it. The typical approach would be to open up your board and go File, Import, Graphics. Here's your board outline. You use edge cuts. I designed in millimeters, so your scale is 1.0. If you designed in inches, you'll have to change that. All right. And of course, it puts the corner at 0, 0, which is up here. I hate the fact this is 0, 0, but it just is. So in this way, you would place your board. Let's move over the one that I did before. And move that over there. Actually, let's just delete this board for now. Go to Alt-3. Yeah, it's malformed. For some reason, whenever I import a DXF or an SVG, it imports it twice. So we click on it once. Oh, no. Enter into the group, and then delete. Delete that polyline. We're left with this polyline edge cuts. We're going to call it board outline. Now when I go Alt-3, no faults, and we've got a rounded board. So that's how you would import the shape. I don't really like doing that because there's no good center on this board. I really like having a center point on the board and being able to update the board as if it's a part, so the same kind of versioning as everything else. Because whenever I'm getting boards made and assembled, the PCB is in so many ways just another component with all of the other components that get soldered down. It just has a bit more customization in it. So instead of importing the SVG directly, I'll make a board footprint. Here's an example of one of the ones that Hobbs Electro-Optics uses. It has the fiducials already, the mounting holes already, and this special outline of the board. Just in there, I have it with semantic versioning so that I can use different variations of the board. Say I've got different cutouts, whatever, but I want the form factor to be identical, so the mounting holes are in the same place, fiducials, all that stuff. Got other examples here. Here's one that goes in the cable cover. Now the board is a little bit of a strange shape, so instead of putting it in the center, which is not really what my reference point is, I put it down here at the edge. Works really well. And again, there we go, 3D model. So, continuing on with the walkthrough, this is the one I already did. So we'll do a new one, create footprint. No, I don't want create footprint. I want new footprint. New footprint. We're going to call this demo board v0.1.1. We don't want any of that stuff. That's the line I copied before. That's not the right one. So I could I could import the graphics. I guess that's what I'll do. I could also go and copy and paste it from the board, but that's cheating. So graphics, import, board SVG, place it 0, 0. Group items. Yep. So now I want a positioning tool, position relative to. I want local origin 0, 0. So that centers it. And I can import this as is if I just want the board outline. So let me show you what that looks like. We're going to get rid of this. Go place. Okay, I want demo board. Go. Board outlines, demo board. So here it is without the mounting holes. Haven't put those in yet. And here we see the part center just like all the others have. Great thing about this is I get to set that reference point when I'm designing the footprint, and it's the same whenever I use this on any other designs. So, okay, okay. Here's some settings that I do want to set in the footprint. Right. I don't want it to show up in the position files, and I don't want it to show up in the bill of materials. This doesn't have a courtyard, but I don't really want it to have one either. It's a board, sleep description board, keywords, board, comma, outline, let's say. I do like putting in the schematic, but you can tick that off and just place it down as a footprint if you prefer. Save that. And key benefit to having this as a component, I've just changed properties for it. I can say update footprint from library. And let's update all of the settings. So I go E, yep. We see our changes to the part have been propagated. And I want to place this at 150, 100, which is roughly the center of the board. And from before, I had already placed the drill file origin and grid origin, but let's say that they are somewhere else. I want to place those on the board so everything is referenced to the center of the board. It just snaps directly to that point, even though it's not on the grid. And yeah, okay, that's grid origin and drill file origin. Look at the, oh, okay. This happens when it imports it twice on top of each other in the footprint. I don't know why it does that. We'll do edit library footprint. We want to enter into the group. Yep, select one of them, delete it, keep only one. Save again. Again, I don't know why it does that. It does that with DXF too, except DXF tends to have some additional problems. On KiCAD 7.0.0, there was some additional problems with DXF that there just weren't with SVG. All right, so update footprint, update, right, and Alt 3. There we go. There's our 3D model. Now, I like, just as I showed before, oh, I closed the footprint editor. Right, so we will go E, edit library footprint. As I said before, I really like having mounting holes and fiducials, cutouts, anything like that already in the board as a footprint, because the way that I see it, it's all one piece. So let's go through the process of putting mounting holes on these things. I'm going to use what I always use, M3s with via stitching. So we're just going to copy this. Pro tip. What it does in KiCAD when you copy is it copies the text. This is in, what is it, S expressions format. So this makes it really easy to copy. It's a feature I like about KiCAD. So we can just take this and copy it directly into the footprint that we're designing, and it just copies everything. I do not want any labeling, any reference designators, or anything attached to that footprint. And I want to group it because each one of the vias is its own part, as well as the top pad and the mask settings. Courtyard settings. Okay, so we've got that grouped. I'm wanting 4 of these, so I'm going to copy and paste those 4 times. I want these to be 4 millimeters from the edge on each side. There's a bunch of ways that I could do that. I'm actually going to try a slightly different one. So let's try position relative to. Normally I do local origin or grid origin, which is in the center. I'm going to see if I can put it on the edge and go -4. Oh, that was the local origin. Alright, even so, it's got the rounded edge, so there's not a good reference point on this curve. That's just a little bit more math than I feel like doing right now. So position relative to, we're going to use local origin. We're going to do some math here. 100 divided by 2 -4. And that's going to be each of 4 quadrants. So see that part got placed correctly. We continue this for each of these others. Just moving into the different quadrants for each. Alright. It's super easy to do the standard positioning, which is something I like. So here we've got the mounting holes all perfectly placed. Let's see. Go, latches on, y is -4 over there, and at this point, x is 4. It's exactly what we wanted. So maybe I'll add fiducials. I think that's in the mechanical section. Maybe it's in mounting. Mounting hole, mounting equipment. No. Marking, mark. Oh, there we go. We can be FCC compliant just by putting it in the silk screen. I like that. That's a lot easier than going through certification. So remember that. Spelling fiducial wrong? I am just spelling fiducial wrong. That is a little sad. Alright, so we've got these nice fiducials already designed for us. We're going to do the same thing, copy and paste. Demo board. put these up in the corner. I want them as far away from trouble as possible. I want these top and bottom, so that's on the bottom silk. I want 2 top and 2 bottom, maybe on opposite ends. I'm going to copy this one. Control C, Control V. Oh, yeah, you really want to group these before you do that. A little bit less tedious if you do it before you copy and paste. Also, you have to delete reference text. This is not something that I want on my final board because these are just footprints. I do not want that text field. So I'm guessing each one of those would come up with X1 when I actually place this part. Alright, so if you're doing this for real, you would probably place these with known locations. You could do position tools, position relative to, and I'll do select item and put it 4 millimeters away from each mounting hole. I did the same thing again. Alright. Position tools, position relative to, select item. It's probably a little close. Maybe we'll make that 10. Make that a centimeter away. Select item. Alright, so there's our fiducial. I'm not going to do this for all of them, but I'll do it for these 2 top and bottom. Alright, and those are close enough. Fine, save the board. Go back over here. Update footprint. Alright, so now it has our mounting holes and our fiducials. And we don't have to do any handwork, it just updates it. So I can lock this, I can use semantic versioning, all of those things. This board only has to exist once, regardless how many versions are using it in other designs. It only has to exist as one footprint that I can update across all the different versions. If we again look at the 3D view, we can see our fiducials. Yeah, so that's how I do that. Export, step file. And all of these are the same. I don't ever touch board center origin, and I do not like using the user-defined origin. That I do in the footprint, and both of these points are superimposed, so they're the same thing. So export the step file. This is the one I did before. You can do file, open, the demo board, the mounting holes in it. And just to drive the point home, when I show the origin, it's centered on the board at the front face, which makes assembly really easy. You can put that into an enclosure and all of the reference points are already set. You don't have to move the reference point, you don't have to move the guide, nothing like that. It just works out of the box every time. And when you make one change to the source, it changes it on all of the designs that you updated. Obviously, use semantic versioning. Don't stomp on all of your previous designs if they're working and already set up. If you make a change to the board, roll the semantic versioning, If it's a little change, change the revision. If it's a larger sort of mechanical change the minor version. And if it's a major shift, maybe you're moving to a completely different kind of enclosure, but it still has genealogy connections, change the major revision. Yeah, that's all I wanted to share.